Okay, let's unpack this. The next time you walk into a corporate conference room, the most dangerous cybersecurity threat might actually be, well, the camera sitting right on the table.
Because that camera isn't just a simple lens anymore. It is essentially a networked computer with deep access to corporate infrastructure.
Right. Which brings us to today's deep dive into the hidden mechanics of modern audio and video routing. We're digging through a stack of product catalogs and technical specs from HDTVSupply.
And the mission here is really to uncover how these complex AV signals are seamlessly managed. Whether you are in a high-tech boardroom or a massive sports bar.
Yeah, and why understanding this invisible AV traffic cop matters to you. Because it really runs our daily digital interactions.
It is a totally hidden world of data routing, but it dictates how we communicate every single day.
So let's start with the conference room. I'm looking at this QSCI USB-BRIDGE. It runs about $2,200.
Right, which sounds steep, but for an AV pro dealing with bring-your-own-device setups, that is actually solving a massive engineering headache.
Because historically, getting high-end room cameras and microphones to talk to a guest laptop without lag was just a total nightmare.
Absolutely a nightmare of proprietary software and drivers. Think about the sheer bandwidth required.
Right.
And routing acoustic echo cancellation, that AEC processing that stops the room mics from feeding back the speaker audio.
But this QST device just uses a driverless USB 2.0 connection. It is essentially tricking a network into fitting inside a single USB cable.
Yeah, it is wild.
It's basically a universal translator for your laptop. You literally plug in one USB cable, and suddenly your personal computer just commandeers the room's networked Q-SYS hardware.
And it pushes up to 1080p video. It simply tells your computer, hey, I'm a standard webcam and speakerphone.
Right, with 0 downloads required.
What's fascinating here is the underlying shift in the architecture. This bridge operates over PoE power over Ethernet.
Oh, wow.
So a single cable powers the device and handles the data transfer over QLAN, which is a fully networked data platform. AV has literally become data packets.
Here is where it gets really interesting, though. Because it's a networked platform, the specs highlight that it receives cryptographically signed firmware updates.
Yeah, they have to treat a conference room camera with the exact same security protocols as a highly sensitive IT server.
Because if a hacker intercepts an unsigned update to that camera, they aren't just watching your meeting.
Exactly. They have a backdoor straight into the company's entire data network. The bridge really is the gatekeeper.
Wow. Okay, so the QSC bridge is managing routing complexity by funneling an entire room's IP network into one laptop.
Right.
But what happens when you have the exact opposite problem? Like you aren't funneling, you're trying to blast 16 different cable boxes to 32 different screens simultaneously.
Without the network completely collapsing.
Yeah. That brings us to the brute force commercial routers in our specs. The Wolfpack fixed HDMI matrix switchers.
Yeah, these things are heavy duty. They are designed for commercial spaces coming in sizes from 4x2 setups all the way up to 16x32 beasts.
And the specs say that 16x32 model pushes signals up to 450 feet over CT6 cable.
Because you can't run a standard HDMI cable 450 feet. The signal degrades and the screen just drops to black.
Makes sense.
Matrix switchers solve this by converting the raw video data to run over CT6 Ethernet cables, which pushes massive bandwidth over long distances with 0 latency.
Why spend all this money, though? Why not just use a simple, cheap HDMI splitter? Like I have a $15 splitter at home that sends my Xbox to 2 TVs.
Right, a lot of people wonder that. But a splitter is really just a cloning machine. It takes one input and makes multiple identical copies.
Oh, okay.
A matrix switcher is like a high-speed rail yard. It routes multiple inputs to multiple outputs totally independently.
I see.
So it allows 16 different video feeds to cross paths and reach 32 different destinations simultaneously without any of them colliding or slowing down.
So the next time you are sitting in a sports bar watching 16 different games on 16 different TVs seamlessly, you will know there's a heavy-duty matrix switcher behind the bar orchestrating all that magic.
Exactly. And because these matrices are built on TCP/IP protocols, you don't even need to be an engineer to operate them.
Right. The bartender can just pull up a web GUI on an iPad and tap a button to switch the feed on TV number 14.
Or an automated system can control it via a legacy RS-232 serial connection. The bartender doesn't see the complexity, they just see the results.
So what does this all mean? We have gone from driverless BYOD bridges that funnel complex AV networks into a single USB port
to heavy-duty 16 by 32 matrices orchestrating dozens of independent video feeds.
AV distribution really does rely on this brilliant invisible infrastructure.
It does. And as AV hardware increasingly relies on network protocols and cryptographically signed security updates, it is essentially becoming identical to IT data networks.
Which leaves you with a fertile question to ponder after this deep dive. As these worlds merge, will the traditional AV technician soon be replaced entirely by cybersecurity IT admins? Keep asking the big questions.